Alright, hello. Kind of talking about the last endocrine gland is the pancreas. So this is the last gland we're going to learn. And then you're going to do something a little bit with the pancreas, and then I have some an activity or two dealing with stress. So this is the last kind of set of notes that we're gonna really do for the endocrine system, I think. So maybe I might have to get a little bit into the sex glands, but we'll see. We will see. All right, so pancreas. Cute little orange kitty with a pancreas plushie. He looks like my cat. Nope, we're not gonna go forward. All right. So the pancreas. So we know the pancreas coming back from the digestive system. We know that it creates and secretes digestive enzymes. So 99% of the function of a pancreas has to deal with the digestive system, right? So there's only actually 1% of the function, which is called the pancreatic inlet, that helps to synthesize hormones and secrete them into the bloodstream. So a very, very small part of the pancreas actually helps to create those hormones. Most of it is used for the digestive system. That's what makes the pancreas very unique, is that it does have those two roles. All right, so there are two types of cells found in the pancreas. We call them beta cells and alpha cells. Beta cells release insulin, and then alpha cells are going to release glucagon. Okay, so what's going to happen is, depending on either one being released, is going to maybe help inhibit the other. When your body is going to need an increase in blood pressure or a decrease in blood pressure, it'll activate these two cells. And then accordingly to whether you need an increase or decrease, those ones will be secreted. So we'll see that in the presentation. So we have beta cells, alpha cells in the pancreas. So, insulin, just real quick, we know it's a hormone of glucose abundance, meaning it sends the message to the body. Cells use glucose for energy and store everything else. It's kind of like the message that it's sending to the body. Right, so what happens with insulin is it helps to control the increase of blood sugar, right, the glucose. There is also something that goes along with the insulin, which is called a gut hormone. So gastric inhibitory peptide, which is GIP, was created when food is in the intestines, responsible for 50% of post-meal insulin production, meaning that you get a lot of insulin production when your food is starting to be digested. That makes sense because as you digest food, you're breaking everything down. So if you're breaking down a lot of sugars, a lot of glucose, your insulin, there's going to be lots of production of insulin, kind of sending this message that we can use this glucose for energy, right? So increase in blood glucose concentration from absorbed nutrients. So insulin is kind of saying, hey, we have some glucose, let's use it, and we can kind of store everything else. All right, so what kind of happens first? Kind of like a little stage of what happens with insulin, like when it's used, and then how it is then stored, right? Because as much as we'd like to believe that your body just kind of takes everything in and uses it at that moment, it doesn't. It needs to store energy for later, especially when you're not active, right? So when you are a lot less active, you're going to have a lot more storage. And that's also why when you're less active, you can accumulate a lot more fat and adipose tissue because you're not being as active using up that glucose. So first things first, insulin stimulates glucose uptake, all right, by fat cells and muscle cells. So the insulin stimulates the movement of transport to allow glucose through the cell membrane into blood cells. So what this means is insulin is going to help take in more glucose by the fat or muscle cells. All right, so insulin is going to then stimulate glucose utilization, just meaning that insulin is going to be, it's going to activate enzymes involved in breaking down the glucose, right? It's glycolysis. We're not going through glycolysis. We don't need to. But just understanding that insulin is going to help to activate enzymes to help break that down so that way it can be used, or that glucose can be used later or really immediately for use. Okay, so insulin stimulates fat synthesis and inhibits fat breakdown. So insulin assumes that the body has absorbed enough glucose to meet the energy needs. So it promotes fat storage by inhibiting the breakdown of triglycerides. What this really means is, or what this sentence is stating, is once insulin has helped your body to absorb this glucose, right? So you had this increase in blood sugar, it's going to now promote fat storage. So after your body uses as much energy or uses as much glucose as it can, the rest gets stored away, which is why this can, again, stimulate fat synthesis, meaning creating more fat. We know fat is the storage unit for all energy. Right, so if I have fat reserves, it's really the reserves of the glucose that was never broken down in the first place and is saved for later. So insulin promotes protein synthesis as well. So the presence of insulin encourages cells, especially in the liver and muscle, to make any protein needed from amino acids. So it also plays a little bit of role in protein synthesis, which we know is very important, since protein is found all over the body for all different kinds of reasons, like immunity-wise, your skin, your hair, your nails, and all of that. So controlling, or the pancreas being able to control the level of your blood sugar, also helps with protein synthesis or creating proteins. So another very important part of different reactions of the body. All right, so this is just a little graphic that you can come back to, and it shows you, homeostasis. Here's like about the normal level of blood glucose level, right? So stimulus, let's say that it rises, right? So we eat a bunch of carbohydrates. So now the body is going to create insulin so that the cells take in the insulin to use it, and then your blood glucose level is going to go back down. And then if it decreases too much, what happens then? All right, so glucagon. So what happens when your blood glucose level goes down? So it's going to be released by alpha cells to increase your blood glucose levels, right? So this is what happens if it goes down too much. This sends a message to save nutrients for the brain, not an emergency. Meaning, it wants to increase the amount of nutrients that your body is going to receive, right? So if you are not eating, so that's why I said fasting state up here. If you're not eating, you're not receiving glucose, you're not receiving something to create energy. So your body says, okay, if we're not getting immediate energy from an outside source, we're going to start looking at our reserves, right? So glucagon is released to kind of signify that you have to start using fat reserves. All right, so glucagon promotes the creation of glucose. That makes sense. So it's going to make your body release the glucose that could be stored, and something called ketones. So one of three things. Glycagon, right, makes your body create more sugar. So we know that glycogen is like a larger type of molecule, so it's getting broken down into the smallest molecule, right, the monomer, like a monomer, like a simple sugar like glucose. So the glucagon causes glycogen to break down into glucose, essentially. Lots of G names. It also helps create glucose from amino acids. That can be done as well. And then it also promotes the production of something called a ketone body from fatty acids. Ketones are kind of like a last resort that your body creates for energy. It doesn't contain as much energy as glucose does, but this is like an emergency. So it's pulling from fatty acids if it doesn't have any source of glucose. So, for example, ketogenesis, right? That is the creation of ketones. That makes sense because keto goes with ketone. Genesis means to create something or something new. So ketogenesis. It only begins after about 8 hours of fasting, meaning you haven't eaten anything for a very long, substantial amount of time, that your body is going to start resorting to pulling energy from other places, which is not a good thing. You don't want your body to start pulling nutrients from places it doesn't need. That is why, eating your 3 square meals with your snacks in between is so important, because you keep that glucose intake at its reasonable level, so that way your body is not pulling from its reserves and then pulling from like almost last case resort reserves, which is like these ketones, right? So you can actually gain a lot of weight from your body pulling from fat immediately. So a lot of times people think when they fast or when somebody is not eating that they immediately get skinny. you actually slightly gain a little bit of weight because you are pulling from fat reserves, and then that's when you start seeing people lose the weight. So it's pretty interesting how that works. But glucagon is promoted when your blood sugar drops too low. It causes glycogen to break into glucose. It can cause glucose to be amino acids. And worst case scenario, your body starts creating ketones, meaning that it's kind of picking from places that it normally wouldn't. All right. And then very, very commonly known that goes along with pancreas is diabetes, right? So diabetes is a result of a deficiency of insulin production or action, right? So your blood glucose can rise abnormally high. So that's why a lot of people have to keep like an insulin pen with them to control their blood sugar, right? So a lot of prominent signs, or a very big prominent sign, is having a large volume of sweet urine. I know that sounds extremely disgusting, but that makes sense because your body is creating so much glucose that it doesn't know what to do with it, that it actually gets rid of it in your urine. You do not want that to happen. You should never see things like sugars, like carbs, really too much in the urine. If your urine tests come back with high amount of carbs, that means your body's not breaking them down, and it's also not storing it, which is not a good sign. There are two types. There's type 1 and type 2. Type 1 is actually more autoimmune, and it can destroy the pancreatic beta cells. This is mostly found in childhood and early adolescence or adulthood. And then there's type 2. Type 2 is a lot more prevalent. Almost like 90% of the cases are type 2. And that's just being resistant of target cells to the effect of insulin. Meaning that for type 2, it just means that there's something wrong with creating insulin, or the insulin is not, communicating with its target cell. So this chart is actually really, really nice. It shows you type 1, type 2, and the differences. Like type 1 is found in early teenage years at first, can be very sudden, very severe. Body weight, you can see a very big drop in body weight. Less than 20% of patients see a genetic influence, right? So you can see how all of this kind of is compared. So treatment would be like having insulin, diet, exercise, being careful, stuff like that. But it's only found in like 10% of all diabetics are type 1. It's kind of rare. You see type 2 a lot more. So a lot more people are type 2 diabetes, which is a lot more to do with the actual insulin hormone, right? Type 1 is more like an autoimmune problem, right? So underlying causes here, this is like your bigger difference between them. So you can come back to this chart and kind of look at the differences between the two. Okay, so that's just my little talk with the pancreas. So you can look back through the notes and you're going to answer the pancreas half sheet. And then technically that is it until we come back from spring break. All right, so thanks for listening. Hopefully it helped a little bit, and enjoy your spring break, guys. All right.